So again, good afternoon, and thank you very much for your patience and welcome for this side event promoted by UNDP. The objective of our side event today is to try to have a comprehensive look in the food cold chain sector. And the speakers that we bring here today are very qualified and experienced in the field. They have participated in actions and projects that try to look into the larger spectrum of the food cold chain, which includes the manufacturing sector of equipment, the application of technology at the end user level, with also looking into how we manage the end of life of these substances, always taking into consideration the costs, affordability, applicability, and energy efficiency. So we hope that today we can bring a spotlight on these actions and foster discussions that can be constructive for the future, for the phase down of HFCs that is starting now with the first key IPs being approved. So with no further, I invite Ms. Saofang Zhou, who is a director of the Montreal Protocol Chemicals and Waste Hub of UNDP, to open the session.
Thanks, Anderson. Dear colleagues and delegates from parties of the Montreal Protocol and many good friends for many years, welcome to UNDP side event of greening the cold chain and best practice of the life cycle management of the refrigerant. It's our great pleasure to have you for this side event together with partners from government and from private sector. So this event, we would like to showcase the real case studies in the field and the result of the project experience and lessons learned. And all of these case studies are closely relevant to the implementation of the Kigali Amendment for the HFC phasing down and also for the energy saving respective. And this is because of the some main reasons. The first, cold chain in Article 5 countries is still dominated by the HFCs with the high GWP at this present. And I think that it's urgent to change the status. The second, the charge of the medium and the large size of the cold chain, is quite higher than the normal air conditioners. So I think that's the big range from 50 kilogram to even to 50 tons in a large cold room. So that means any new installation with HFCs, current high GWP HFCs will pose a risk to the party who ratify the Kigali Amendment. So that's urgent need to introduce new technology and efficient. And the third reason is data shows that the emission from the cold chain system, particularly from large system, are quite high. And this means that the direct threat to climate change, but also negative impact to the energy consumption and also the increased demand for servicing. So for all of these reasons, I think it's important to prioritize the phase down of the HFCs in the cold chain in the beginning of the Kigali Amendment. We heard this morning in the discussion with the plenary that many delegates indicated the big challenge of the refrigerant life cycle management. We are very glad that in this side event, we will invite a world leader in this regard to introduce their solutions. It will be very interesting, I think, for all the parties to consider. And UNDP has been working with governments and partners in past several years in the cold chain, to introduce the low GWP and efficient technology. In many cases, actually, this is the first time to introduce this technology in the local market. And I think the achievement is quite significant. So today, here, the other speakers will introduce the real result, and they are the real heroes. I think we are very proud of being, involved in this technological innovation development process. We are supporting the private sector, supporting the government to, to install the new technology in the local market, but also develop, national and sector strategies. I hope all of this experience will be helpful for the parties to consider, your activity, your strategy in the implementation of the Kigali Amendment. And I think that cold chain is one of the pillars of our economy and society, and it was recognized, so important, over the pandemic. And we see a lot of demand from the community to the cold chain solution. So we are passionate to support all of the parties and government to take ambitious and action, and to introduce the efficient and green technology in your country, for sustainable development. It is not only about the refrigerant. I think it's about everything for our society development. So this is, I think this is an opportunity for us to get together and discuss and share those information. And we'll be very happy to, have further discussion after this side event. And with this, I think I want to close my remark very briefly, and thank all of the speakers and audience. So hope you will enjoy this side event. Thank you.
Thank you, Saofang. Our first presenter is online, Mr. Edwin Dixon, who is a technical advisor to the National Ozone Unit of the Ministry of Environment of Colombia. Edwin, can you hear us? If okay, you can go ahead with your presentation.
Good afternoon. Yes, I can hear very well.
Okay, we can hear you also. So yes, please go ahead. Thank you.
Good afternoon, everybody. This is my presentation. I'm talking about the green supermarket strategy that we have in Colombia. This strategy is about the commercial refrigeration systems. It's good to clarify that this strategy does include refrigeration systems. It doesn't include air conditioning systems. This is a national strategy that for the implementation of the measure and alternative that improve energy efficiency and the direct environmental impact of the commercial refrigeration systems of the Colombia supermarket subsector or store subsector. It was made between 2019 to 22. The first step for making this strategy was to create a working group with this subsector and make a lot of meetings with this actor, because it's necessary to know very well what is the barrier that the supermarket is going to have when implementing definitely alternative. The second step is doing the technical characterization of commercial refrigeration systems and make the business as usual scenarios about the technologies used by supermarket. The third step is define alternative for each time of the retail. All need to note very well what is the alternative that are available in our country. And the fourth is about the making reduction scenarios. These reduction scenarios, what will happen if the supermarket success to reuse it, and definitely alternative. And after this kind of the aspect, we have included in this strategy or related to the education, training of the services sector, and technical standard, and include the financing alternative that exists in the country for supporting the capex, this capital expenditure. Finally, this strategy have the roadmap of each kind of the store. But in this structure, you need to add another year, because this is a document. And if you want to accomplish with the roadmap you should work with these two aspects. You need to develop out of demonstrative project or pilot project, and you need to define an economic mechanisms for implementing the roadmap, for looking budget and initiatives that have capability for supporting the strategy. This is the document about this strategy in Colombia. This has 8 chapters. The first is related to the background, Montreal Protocol, Kigali Amendment, another kind of the standard regulation about the energy efficiency. The chapter 2 is the characterization. In this part, you can find the type of the equipment and systems, the estimation of the direct environmental impact, or the estimation of the indirect environmental impact too. The chapter 3 is about the reference scenarios. In this part, this is the projection of the, for example, energy consumption for the period 22-2030. And in this chapter, you can find the projection of the equivalent environmental impact and an annual emissions. The 4th chapter may be the most important. This is the measured and alternative. In this chapter, you can find the measured and technical alternatives with better energy efficiency and ultra low of direct environmental impact. In this chapter, you can find alternative for new equipment and system, but you can find alternative for equipment and system in operation. And you can find another alternative for system at the end of their useful life. The chapter 5 is the reduction scenarios. In this chart, you can find 2 kinds of the scenarios. The DR is in Spanish, DR. This is the introduce of the natural refrigerants that have ultra low GWP values. But there is another scenario that is the direct. In this scenario, this scenario incorporates of the ultra low GWP refrigerant, but plus or related with the alternative with energy efficiency improvements. The chapter 6 is about the training and education. The 7, the finances alternative, and the 8 is the roadmap, that is the strategy, issuing, time, and actor. In the next slide, I'm going to show a little more about this strategy. This is the characterization of the commercial refrigeration systems. In Colombia, we have 5 types of the supermarket or store. The graph on the left shows how is the participation of the supermarket in Colombia. Convenience stores are the most representative, and the hypermarket are the least representative. The trend in Colombia is the convenience store. They are growing rapidly. In the graph on the right, you can see the number of the type of the equipment or system by type of the store. For example, you have the opportunity to visit a hypermarket in Colombia, you can find 2 centralized systems and 34 standalone or self-contained. It's really important, this amount of the equipment. In this graph, you can see the amount of the refrigerants. On the left, show the amount of the refrigerant gas in kilograms for store type unit. This value is the result of adding the installed refrigerant plus the average annual consumption. This last value is the leakage of the each kind of the store or of this kind of the refrigeration systems. In the graph on the right, you can see the amount of the refrigerant gas in kilogram for the total store type. In this graph, this is the kilowatt hour per unit of store type. The graph on the left shows the kilowatt hour per unit of the store type. For example, the energy consumption of the refrigerant system and equipment in a convenience store is the 8 kilowatt hours. These values were calculated through an energy meter or a power meter. These trials were carried out over 2 weeks. The graph on the right, you can see the kilowatt hour by type of the store nationwide. This is a difference between this kind of the store, the hypermarket, convenience store, This big difference that you can see in this graph is due to the type and the size of the systems. And this is an example about the business as usual scenarios. This is the reference scenarios. This graph shows the business as usual scenarios, how the equivalent CO2 tons is increasing due to direct emissions during the operation of the systems that are using refrigerant gases with ODS or high GWP. These are the leakage of these systems. And the blue line is how the equivalent CO2 tons is increasing due to the direct emissions that turn out at the end of the useful life. This is the line blue. And the yellow blue line represents how to increase the equivalent CO2 tons due to the indirect emission or energy consumption. This is the total emission in Colombia. This showed the total emission in the supermarket subsector. It is the total environmental impact of the country's store sector in equivalent CO2 tons. This is a projection to 2030. And this is an example about the technical and economic sheet on the alternatives. This is one of the technical and economic sheets that we have on the alternative and measure. This document has 22 sheets. This alternative can be applied to the new system as well as those that are in operation and those systems that are at the end of their useful life. These sheets are divided in 3 parts. One of these is a description of the measure or alternative. The second is about how is the alternative will reduce environmental impact. And the last one, maybe it's the most important, that is about the economic aspect, where you can find the CAPEX and the OPEX and the payback for each kind of the alternative of measure. This kind of the sheets are really complete. This is an example about the reduction scenarios. This graph shows the reduction scenarios, how direct and indirect emission decrease as the supermarket subsector implement the alternative and measure of the strategies. This is a projection to 2030. In the next slide, you can see all related with the training and education. You need to consider in this strategy another topic or aspect really important. For example, all related to the certification of the technicians, all related to the Colombia technical standard, and the promotion of the refrigerant gas recovery, recycle, and regeneration network is really important in this chapter of this strategy. And finally, this is the roadmap general for all type of the store. This is the roadmap general because this document of this strategy has a roadmap for each kind of the store. And you can see the period of this roadmap in this part, and you can see in here part the measure alternative, the training education, the policy regulatory instrument, and the economic and market instrument. And this is the total emission, the reduction emission, the total reduction emission that we have here in Colombia if implement this strategy. The achievement of these scenarios depend on the intensity and penetration of the implementation of this measure alternative in the new system, in operation and the final disposal. A reduction of the 50% is estimated in 2030. In conclusion, this strategy and the step for its construction will be replicated for the rest of the actors in the food cold chain. At the moment, Colombia has a national strategy for commercial refrigeration system and equipment in supermarket sector. Next, we are going to work in the same strategy, but we are going to include air conditioning systems, another alternative. And the next year, we are going to work in the strategy for the distribution subsector, all related with the food distribution subsector in Colombia. Making a demonstrative project is a solution for supporting all the work that have been developed. for implementing the green strategy in this subsector, especially when it tries to implement a new technology according to the cycle of life of refrigeration systems. Finally, this strategy aims to achieve a net zero food cold chain and support the phase out HCFC and phase down of HFC in our country. This is my presentation. Thank you so much.
Thank you. Thank you very much, Edwin. Before we go to the next presentation, I think we have a couple of minutes to follow up questions, maybe one or two questions if you want any clarification now. So let me see. Okay, no questions for the moment, but Edwin, please bear with us because we will have a larger question and answers session in the end. Thank you very much again for your time and interesting presentation. I will now invite Ms. Claudia Paratori Cortes, that is the National Ozone Officer of the Ministry of Environment of Chile, and Mr. Pierre Zequeto, who is an independent consultant to UNDP, to present us the experience of Chile in adopting transcritical CO2 technology. With a specific role of the assembling sector and also from the explaining the public policies and strategies that underpin this very ambitious and successful project. So, I don't know, Pierre, you start.
Hello. Hi, everybody. I am honored and it's a pleasure to be here. I will be the first one talking. Then after I'm finished, Claudia will say the relevant things. And at the end, we have a testimonial video from the end users, which is the most important part because it's what is really happening. No, it's not. We have a small technical problem. Maybe there. Okay. Okay, there we go. This initiative is 10 years old. It started on 2014, and it's an odd thing that it was the public sector that was trying to push the private sector into doing business. Usually it's the other way around, okay? And the strange thing is that the CAC and Multilateral Fund and UNDP and the Ministry of Environment had money and had no one that wanted to use that money, which is even more strange. At that moment, worldwide, there were only 3,000 stores with CO2, and Chile had no experience at all on CO2. The budget was very nice because they want to make a couple of demonstrations, and there were more than $700,000. So they put everybody together, supermarket companies, Chilean Chamber of Refrigeration, designers and installers. And on 2 years, the project was not successful. So that showed that money is not enough. It's necessary, but it's not enough. So what they did is they analyzed what they had to do to have success. So the first thing was target the right sector. And the right sector worldwide was supermarket and retail industry. Okay? And then supply the sector with enough things to avoid excuses. So they had to say yes, and they could not say no. And then they defined the needs, which were for basically financial support. They had the money. Okay, they wanted 3 projects. Then, since Chile is a small country, far away, we brought people from elsewhere. So because we always hear more people telling us stories from other parts of the world. So workshops were conducted, and then we trained people. And after that, we also needed equipment and components. So we facilitated with all the main suppliers worldwide to have enough things to do the job. And then experts came. We trained people in Europe, and we went to Febrava, which is an important show in Brazil. And then we started to move from, I have no idea, I don't care, into better take this bus because it might be successful. And for businessmen, successful is making money and having a good image. So the support of UNDP, CACC, MLF, also with the main supermarkets, because as we will see, this was the focus. Work with people that could make a change that would be followed. And then what we obtained is that it was successful. We planted 3 seeds that were 3 trees, okay? The question is that enough to have the industry going by itself without subsidizing it? Okay, that is what we were trying to find out, given numbers. This is the position of the CO2 transcritical systems worldwide. We can see that Europe is so far the leader. They started on 2008 with 100 stores at that time. And we see that Japan also is pushing hard. And US is lagging a little bit behind. But we think that now that is a good business, they will really start also pushing. This is what we had. On the right, you have the profile. Supermarkets are 4% of the total economy in the country. And you usually test if something is good when times are hard. And we had 2 events, which were COVID, we all know that, but we also had a social unrest. And that social unrest, it cost us 9% of all supermarkets were destroyed. Okay? So we have the same number of large supermarkets from 2014 that we have today. And that is a big temptation to go back to what is the cheapest and the most simple. Then is where and when you test if you were able to create a successful story. So for me, we had, this is important, 4 companies that control 90% of the market. And we still have them today. Okay, and we also find out, this is public data, that almost 90% of the population wants to go there. So if we change supermarkets where everybody goes, that controls most of the economy, we turn them into sustainable solutions, then for us, that is success. And this is the graph in the last 10 years, 9 years, with the curve that we have with large supermarket installations for transcritical CO2. And if you see, oh, no, there, okay. If you see, is tries to simulate the European one. It's better than the American one. It's not as good as the European one or the Japanese one. Okay, and this for me is the most important slide of the presentation. Here we have the penetration of the market. And in the penetration of the market, we see Europe. 1 of every 5 stores is already with CO2. Then we have Japan, which has 8.6%, but many small stores. And then we have the North American market, United States, with 2.2%. And since the initiative started before, is giving his fruits sooner, 5.8%. So it's not just a matter of money, it's how we work together. And what happened on 2017 when we set up the first stores, and today, here in the bottom is what is really sustaining the effort, is what is making it possible without subsidize, okay? And then first thing is equipment is easily available. It costs only between 5 and 10% more than standard HFC equipment. Second, the cost of refrigerant before was CO2 was 50% more expensive than an HFC. Now it's 20 to 40% less expensive than HFC. And we know that the leaks are an important issue. Now, then if you have a leak with CO2, it will cost you less money than if you have it with R22 or R44. Then installation, which is CapEx, before installation was 35% more expensive than standard HFC installation. Nowadays, it's between 0 and 10%, depending on the format of the supermarket. So these are sustaining, these are making a good business, okay? But then you have to service the systems. At the beginning, we had one company, and we all had an insurance on the company, because if they fail, the system would collapse. Now we have 6 large companies able to do installation and remote monitoring of the system, which also implies monitoring the equipment and monitoring energy. Okay, then retailers on CO2. At the beginning, they were 40% of the market. Some international retailers didn't want to work with that. They say it's not a business. Now all the retailers are doing CO2 projects, which means that the transformation of the system, which is 90% of the market share, are beginning or using CO2 in new stores and retrofits. And then efficiency. At the beginning, papers indicated that CO2 could be more efficient than R404 or R22. Now they have made the studies. We gathered data during 3 years, and this is what we have, not measured by us, measured also from independent companies. And this is making it a good business. Consider that the supermarket, a large one, can spend $50,000, $60,000, $70,000 per year on energy. That means they're going to be saving between $20,000 to $25,000 on energy per year, and that is going to go directly into profit. And again, training options. At the beginning, training had to be abroad, and now there are local training centers being developed. And finally, reliability. We have measured that service standard is 50% lower on CO2 systems than HFCs. So finally, we have most of supermarkets are operating with CO2, and the best of all, no subsidized, and they have it on their standard specifications when they do any tender. And that's my part, and I thank you very much, and now invite Claudia for the following part of the presentation.
Okay, next, please. I will present you a brief summary, because we don't have enough time, about the synergies and challenges from the point of view of the National Ozone Unit. So this it shows our current situation, where we have the Montreal Protocol and the amendment as the main part of our work, with the challenge to eliminate HCFCs and reduce HFCs, improving energy efficiency, and also avoiding the use of HFCs. So as tools in our daily work, we have the HPMP, the Recovery, Recycling and Reclaiming Centers. We have 4 in the country.
and also the KIP, which we are preparing, and hopefully we will present it at the end of this year. But to support, this is our internal working area, but outside that we have two binding instruments, which are the Framework Law on Climate Change. This law was approved last year, with the NDC, National Determined Contribution, that contains the commitments of Chile under the Paris Agreement, and its long-term climate strategy that contains the national, regional, and local activities, and very, very specific one, where we as Ozone Unit can share the activities on HFCs reduction. By the other hand, we have the law on energy efficiency. It was approved on 2021 with it is implemented under the National Plan on Energy Efficiency, and specifically in the related to the refrigeration and air conditioning sector. It has the strategy on heat and cold. A quick review on these two binding instruments. The Framework Law on Climate Change has the main goal to be carbon neutral on 2050, with two steps in specific in the RAC sector. One is to have minimum energy performance standards for residential appliances on 2030, and for all RAC commercial, residential, and public equipment on MEPS on 2050. By the other hand, the strategy on heat and cold has three objectives. One is related to the total sustainable energy used for heat and cold, with two steps: the reduction of greenhouse gas emissions, that means HFCs, and the percentage of population that will fulfill their needs on heat and cold on 2015. The next one. And finally, why we are supporting as Ozone Unit, why we are supporting the transcritical CO2 technology. The first one is because it is a natural refrigerant, no HFC. We are developing a campaign saying HFCs are not ecological, because there is a commercial campaign that HFCs are ecological. It has a very low energy consumption, but it needs trained technicians. As you have heard from Pierre, it's a country-proven technology. It has economic benefits due to energy savings and reduction of leaks. And for us as Ozone Unit that belongs to the Climate Change Division, contributes to the mitigation measures under the long-term climate strategy. And the most important for our project it is replicable. That is, thank you. And now we are going to watch the video.
En Cencosud aspiramos a mejorar la calidad de vida de nuestros clientes y de las personas a través de una oferta de productos y servicios con valor diferenciado. Esto en concordancia al desarrollo sostenible, donde tenemos, por un lado, integrado el crecimiento económico, el bienestar social y el cuidado del medio ambiente.
El supermercado Cencosud Chile tenemos un profundo compromiso con el medio ambiente y con el protocolo de Montreal. razón por la cual desde ya hace años comenzamos con el recambio de sistemas de refrigeración de R22 a CO2 transcrítico.
El principal motivador de este cambio tiene que ver con nuestra estrategia de cambio climático y nuestro plan de descarbonización. Es un camino y una responsabilidad que conlleva también con el entorno, el medio ambiente y nuestras comunidades.
Comenzamos en el 2017 en Jumbo Valdivia, convirtiéndose en el primer supermercado de Chile con esta tecnología. Por un lado, reducimos las emisiones que dañan la capa de ozono, pero también hay toda una eficiencia en el proceso de refrigeración y en el consumo energético. Todo este trabajo lo iniciamos de la mano en un trabajo conjunto a la Unidad de Ozono del Ministerio de Medio Ambiente el 2017, que nos ha permitido avanzar y ser líderes a nivel nacional en esta gestión.
Esta mirada está integrada en los 6 países donde tenemos operación, en las 1.400 tiendas y en 67 centros comerciales.
Es por esto que desde Jumbo y Supermercados Cencosud Chile invitamos a las otras empresas, a las otras industrias a sumarse a iniciativas como esta y tomar el desafío de ser un real aporte al medio ambiente.
Thank you very much, Claudia and Pierre. The same way I will open the floor for the maybe 1 or 2 immediate follow-up questions if you want to make. Please, can you identify yourself to the speakers? So, thank you.
Thank you very much. My name is Idris Abdullah. I'm the National Ozone Officer for Nigeria. Yeah, I wish to thank them for this wonderful presentation. It shows a good example of what we call the leapfrogging, because it was done even before the adoption of the Kigali Amendment. So having adopted the Kigali Amendment, I want to ask, was energy audit done before the energy audit of the project, was it carried out? Thank you.
Hello?
We have another question there. Just Pierre, if you can just take it, maybe the questions for you. So. Please go ahead, sir.
Yeah, thank you very much. And we thank you for the presentation. I want to find out whether the choice of CO2 technology depends on the climatic condition of the country where the installation will be done. That is first. And the second, how does the ammonia technology compare with carbon dioxide technology? The benefits of each one and how you would evaluate the performance of each. Thank you.
Thank you. We have just one more question and then we will go to the answers because we have another presenters, but just to advance a little bit of the question, and I don't want to step in appear technical grounds, but we know that CO transcritical may have some challenges in hotter countries, which I see many countries here have a more are in a higher temperature scale. That's why we also invited the company Moontech that will present in the following session, that we will discuss a little bit of their technology that is subcritical CO2 in cascade systems, and could also be another technology for you that is highly efficient. So the last question, and then we will ask Pierre and Claudia to address the question. Okay, so Pierre, floor is yours.
Okay, regarding the first question, yes, an audit, energy audit was made. It took 2 years. All instrumentation was calibrated, and one of the audits was doing by 2 companies independent that didn't know each other. So the data you see there in the presentation is a consequence of the numbers that came out after 2 years. Okay, and specifically, the customer wanted, because they have a sustainability chapter, They are quoted on the stock market, and therefore they gain points if they show sustainability and efficiency. That's for the first question. Regarding the second one, today transcritical solutions are so evolved, not like 10 years ago, that can withstand any climatic condition. There is no quarter for the replication, and they are efficient. Now, if you go specifically into the supermarket and retail industry, let's say that maybe 3, 4, 5 supermarkets have been work with the combination of ammonia and CO2. All the rest, which is close to 60,000 installations, is just CO2 transcritical, because it's one single supermarket, it's efficient, and it's quite safe. And you have to remember that in supermarkets, you have a lot of public. So even if you have 40, 42 degrees Celsius ambient temperature, you can have an efficient and reliable solution with transcritical CO2, that it's proven also.
Thank you, Pierre. And I would ask now to hold your questions for the last session. We will invite then Mr. Shimei Hao, who is the General Manager of Moontech Thailand, which is a subsidiary of the Moon Environment Technology of China, to give his presentation.
Good afternoon, ladies and gentlemen. I'm Mr. Hao from Moontech. It's a great honor to be invited to share some experience on green technology innovation and marketing application of the large-scale cold chain infrastructure in China. First, let me make a brief introduction about our company. Moontech was founded in 1956, and now it's a leading company for some smart energy management company. Now we can control the temperature from minus 271 to plus 200. Okay. And present Moontech has 9 industry parks all over the world and can serve 220 countries all over the world. The main business covers low temperature refrigeration solution, central air conditioning, eco-friendly heating solutions, energy and chemical, pressure casting, and some new business like hydrogen business. Some overview of large-scale green technology. Moontech started to study CO2 system since 2005, and please go ahead. Go ahead again. Okay. In 2006, we completed the first national level performance, high performance laboratory in China. It's special for CO2 system design. And in 2006, we the first set of CO2 compressors, cool compressor, and the related equipment manufacturing in China. And another one. Okay. Actually, actually, in 2009, we completed the first practical large-scale CO2 system in China. It's a food processing plant. It's for seafood, opposite of our head office. And in 2010, Moontech CO2 system equipment was listed as the national key new products by many mainstream science and technology of China. And the demonstration project of replacing R22 with ammonia CO2 cascade system is past the acceptance of state Ministry of Environmental Protection, and by Montreal Fund. This is another project for logistical warehouse. The next one. Actually, our demonstration project of CO2 refrigerant system was awarded by Chinese government. This is in 2014, key technology research and system development application of CO2 cascade refrigeration system won the certificate of special award of CRA. This is the new update of CO2 semi-hermetic screw compressor. Some new products and also new products. This is because of CO2 cascade system, and we got some award by UN module for the protection of ozone layer. This is the module. This is the certificate. Yeah. And up to now, this is in 2015, the 100th CO2 system was signed, and actually up to now, we made over 500 CO2 ammonia CO2 cascade system in China already. And the Chinese safety regulation for CO2 refrigerant system is completed, and the standard is made by Montreal, filling in the gap of related relevant standard for CO2 refrigerant system. Some new actually for CO2 cascade system, it's not only ammonia CO2, also some freon CO2 cascade, different kind of freon, up to some government control, government policy, some new. Okay, one. This is the some new technology. Okay, here. Actually, maybe you are more interested in what kind of business is suitable for CO2 system. Actually, it's quite used like a food, seafood, meat, beverage, brewing, coating, logistic, chemical, construction, and also ice and snow environment technology. It's widely used in almost all business, but not suitable for some more retail, some supermarket. It's not quite suitable for cascade system. Okay. Some future work. We want to how to say? We want to organize everyone to develop the technology to for all temperature and all pressure solutions from like not only refrigeration, also like hydrogen, nitrogen, some different kind of refrigerant freezing technology. And another side is for some green refrigeration for the marine refrigeration area. Another way is some new refrigerant like ethylene. Now I share some more project pictures. This is the chicken slaughterhouse project. Normally, it's used the ammonia system. Some cases with freon system, but now the ammonia CO2 cascade system and the secondary system is widely applied in Chinese slaughterhouse business for not only for chicken, for pig, for all kinds of slaughterhouse. This is another project. This is special for R507. It's not ammonia CO2. So another sample projects. This is for CP China. It's a heat recovery for what we call the total heat recovery system. This is the first large-scale logistic warehouse in China with ammonia CO2 system. This project is made in 2012. It's almost more than 10 years. This is one squid processing plant with the ammonia CO2 system. Maybe some guys are more interested in the energy saving and the investment, and why we choose the cascade system. For CO2 for CO2 system, it's for ammonia CO2 system is higher efficiency. Normally it's up to the efficiency is up to project size. Normally we can see 15 to 20% energy saving, and the first time investment is about 20% more, but it's up to different projects. This one logistic warehouse in China. It's the capacity is more than 200,000 tons. This another Guangzhou Nansha Port. This the capacity of about 200,000 tons. Another logistic warehouse. Actually, this project is designed by me. Okay. This is the Yili Group. It's a Chinese beverage company. Actually, this is the first time to use the ammonia CO2 cascade system in ice cream industry, and now it's good running. Actually, there is one project in Thailand. It's also CO2 system. It's running now. This we did a CO2 system for Beijing Winter Olympic Games. Different projects. Okay. This some R290 CO2 cascade system for some special industry area. This for ice making project. Normally for ice plant, ammonia system is popular, but it needs a high maintenance, more maintenance, and more risk. This some projects all over the world. We also did a project for this located in Malaysia, and the next one is in Indonesia for some logistic warehouse. This project in Bapentani in Thailand for beverage ice cream plant. These are all our cascade system all over the world. Okay. This is my presentation. Okay, thank you.
Thank you, Mr. Hao. I don't know if there is one question from Roberto Peixoto. Yeah.
Roberto Peixoto, UNDP RTOC. Thank you for your presentation. You mentioned several applications of industrial refrigeration where ammonia is the leader refrigerant. So what are the motivations for using a cascade system ammonia CO2? Decreasing ammonia charge, energy efficiency? It was not clear. If you could elaborate a little bit, because in general, the industrial refrigeration, you have all the safety measures, so that wouldn't be a problem to have just ammonia, a pure system. Thank you.
Yeah, this is a good question. Why we choose the cascade or secondary system? For some bigger scale, the logistic warehouse, normally it will charge a bigger quantity of ammonia. For example, we have some projects in China, it can charge over 40 tons ammonia. It's a big risk. If with a cascade system, it can reduce ammonia charging 90%, 90% off. It means we have a project here. If with the ammonia system, we will charge 2 ton ammonia, but we choose the CO2 ammonia CO2 cascade system. We charge only 196 kilo ammonia, and the ammonia only run in the machine, and CO2 went to the processing hall, went to it's easy to control the risk. This is the reason. First reason why we choose the cascade system. Second, the CO2 is suitable for low temperature conditions, like for air blast, for IQF machine, for some low temperature logistic warehouse. And the efficiency, its efficiency is higher than pure ammonia system. This is the second reason to choose the cascade system. The third reason is the full automatic control. So normally now CO2 system is with a full automatic system. No, it's not high requirement for the operator. Easy control, easy operation. Yeah, and so low risk and low running cost. That's why cascade system is more popular in China now. Okay, thank you.
Thank you, Mr. Hao. Now we are going to the next presentation about the best practices and end-of-life management refrigerant that will going to be delivered by Ms. Louise McCann, Global Commercial Director of AGAS, and Ms. Elvira Nigido, the Group Sustainability Compliance Manager of AGAS. So the floor is yours.
Oh, as I can start. Thank you. Good afternoon, everyone. Great to have this opportunity today to talk to you all a bit more about life cycle refrigerant management. It's a term you'll be hearing more and more of. So this is our opportunity to really define exactly what this means and talk about these activities that will be enablers to ensure we see more of this activity in the future. First of all, just to give you a little bit more information on AGAS, which is the company both Elvira and I are from. AGAS is the global leader in life cycle refrigerant management. The company will be 30 years old as of this year, and we have more than 15 years of experience in recovering and reclaiming or recycling refrigerant gases. We have more technology in this field than any other company globally. We also have destruction technology. So in that case, we're able to provide that fully circular model of recovery, reclamation, and destruction in different avenues in different countries around the world. We're very proud of our abatement achieved from life cycle refrigerant management. So in 2022 alone, we abated 8.6 million metric tons of CO2e from our activities. We have committed to be net zero by 2035 and to reduce our emissions by over 50% by 2028. So this is probably the key slide for those of you who are hearing this term nowadays, life cycle refrigerant management, and wondering what that means. And it's key to say it all starts with recovery. In our business, we talk about recovery of gases being our #1 strategic pillar. Recovery in a safe and compliant manner is something that we see really very little of today globally. Even in countries where it is mandated that people should recover, the reality is the majority of refrigerant gas today is vented to atmosphere. We need to curb this, and this is the key activity to ensure we do so. After refrigerant's been recovered, we would specify that where it's eligible to do so, so where there's still a demand for that product should be reclaimed. Why is that? Well, by reclaiming or recycling refrigerant gas and putting that back out there, it stops that requirement for a virgin kilo or pound of product to be created. However, there are circumstances where it isn't eligible or doesn't make economic sense to reclaim refrigerant gases, and therefore we should say they should be destroyed at end of life using the right type of technology. That's also an important aspect. The technology that we use is TEEP approved, pyroplast technology. And then with that reclaimed refrigerant gas, we're supplying it back. So we're supplying back reclaimed refrigerants, which are AHRI 700 specifications, so equivalent to virgin product, back into the marketplace where that's allowed. With that product, we also supply the full portfolio of other refrigerant gases and low GWP alternatives. So it's really giving that whole range of offerings to the market.
Good afternoon. Good afternoon, everybody. Elvira Nigido, Group Sustainability Compliance Manager for AGAS. So in order to achieve net zero and to support industry move towards lower GWP products, we also need to take advantage of life cycle refrigerant management. And there are a number of key pillars that will enable that process to occur. So enhanced product stewardship, that's one of the pillars of LRM, and that's about producers having responsibility to put programs in place to promote product stewardship, refrigerant recovery, reclamation and reuse. So what are the incentives that we need to implement to encourage recovery and reuse? As Louise mentioned, a lot of the product does get vented, and we want to be curbing that as much as possible. Further to refrigerant recovery, reclamation and reuse, we want to ensure that we've got leak reduction measures in place. We want to be able to identify leaks in systems, and rather than top up systems with refrigerant, we want to be addressing those leaks, stopping the leaks, therefore, having positive environmental outcomes as a result. Reporting and enforcement, that plays a very key role in the whole LRM process, ensuring that we've got a level playing field whereby, regulators are putting regulations in place, policies in place, undertaking enforcement activities to prevent emissions. Furthermore, workforce development, we've seen that in previous presenter slides whereby we need skilled and competent technicians and operators operating equipment, whether it be recovery equipment or as we move to lower GWP products, understanding how those systems work and making sure that they've got the right skill set to maintain those systems in a safe manner. Furthermore, installation and servicing, we want practices being implemented whereby during service activities, equipment is being maintained correctly, refrigerant charges are maintained, and the equipment is operating in an energy efficient manner. And then finally, at end of life, when there is no requirement or no further requirement or further demand for reclaimed product, we want to be able to destroy it so that it's totally removed from the supply chain and we've eliminated all potential for emissions. Next slide. So the importance of recovery. Again, to Louisa's point, recovery is key and critical to LRM. We've, through COPA, we estimate that 1.5 gigaton of emissions occur on an annual basis. That's equivalent to about 440 coal-fired power plants. So that's the amount of environmental impact that it is occurring annually. In AGAS's core markets, we see that about 75% of refrigerant is not recovered. In other words, it's being vented to atmosphere. We know that the demand for cooling is expected to grow, especially in A5 countries. And we also know that HFC banks will continue to increase and dominate volumes of product going into the 2030s. Overall, HFC banks, installed banks, are highest in developed countries, and a lot of the equipment in those countries will reach end of life by about 2030. So the risk of emission is quite imminent and close to where we are now. So therefore, recovery minimizes direct refrigerant emissions. So therefore, HFC recovery, CFC recovery, HCFC recovery has to be part of every emission reduction strategy.
I'll put this one down, given it's not working anyway. Okay, so with recovery being so important, and today us seeing so little of it, what do we do? How are we going to ensure that we're achieving higher rates of recovery in all countries? To me, firstly, it's about education. I think the majority of people want to do the right thing. They just don't know. They don't understand, firstly, the impact that the venting of refrigeration gases has on climate change. And then they don't have necessarily the know-how in terms of the training to be able to properly recover refrigerant gases in a safe and compliant manner. Once you have that knowledge and education, we also need tailored offerings that make it easy. So when I say that, it means, you know, the way in which you'll recover through contractors will be different to perhaps through wholesalers or different market segments. These brand names you see there, the AGAS, Rapid Recovery, Rapid Exchange, and RefReclaim, are different recovery models we have for different channels. So if you take the example of Rapid Exchange, that's, you know, well placed with us in the US, whereby we're going directly to contractor sites and dropping off empty recovery cylinders to them for them to use on jobs. Then we'll return the next week, pick them up and take them back. So it's very simple, but very effective for contractors who want to have the majority of their time on the job. They don't want to be thinking about the time and the hassle involved with recovering and having to take the cylinder somewhere else to drop it off, or making sure they have the appropriate cylinder available. That's an example of a model, as I said, that we have well advanced in the US. Right now, we're rolling that out in Italy, in Japan, and in New Zealand. So with each of these different tailored offerings, we're rolling them out, you know, globally as markets mature. We also would ideally like to be able to offer incentives to ensure that there's something in it for those people who are doing the right thing with terms of recovering gases. And that's where there's then a link up with carbon markets. You know, for us, being able to develop carbon offsets from a lot of this activity is essential. So we want the methodologies that support that practice, ensuring equally that these are of high, you know, integrity to the market. These incentives then also help, you know, ensure that we can develop this technology, which is, you know, very expensive to implement in terms of separation and destruction.
Yeah. So reclamation. Reclamation's about returning the recovered refrigerant back to AHRI 700 specification, or very close to that specification, because we also recognise that not everybody has access to reclamation technology that can get it back to that. So the reclamation process can involve filtering, drying, removing non-condensable gas, separating refrigerant components, again, all with the view of getting refrigerant that meets that AHRI specification. From time to time, we're going to need to use virgin products to reblend refrigerant and get it to that specification. Having access to laboratories or testing facilities that can determine, well, how well has that reclamation process been? How successful has it been to get it to that AHRI is also key and critical, because at the end of the day, you need to ensure that that recovered refrigerant that has been reclaimed is fit for purpose. Separation and reclamation of processed, beg your pardon, sorry. We will often see cocktails and mixtures of refrigerants come our way. So therefore, reclamation, separation using distillation processes is very important in being able to separate refrigerant components and making sure that they meet that spec and meeting the right composition. As a company, we've invested lots of money, millions of dollars in reclamation technology around the world. We have quite a number of reclamation separation towers in numerous locations, and therefore giving us capacity to take used refrigerant, mixtures of used refrigerant, and returning it back to spec.
Are we running short of time? Okay, well, we'll finish on this slide, which is probably a good one in terms of a message to end with regards to, why is reclaimed refrigerants and giving access to reclaimed refrigerants so important to support that transition to low GWP. As I mentioned previously, for every reclaimed pound of product that we create, that's a pound of virgin product that doesn't need to be created. So there's a huge benefit there, understanding that there's still new equipment today going out into the marketplace, which runs on HFC, which will have a lifespan of potentially 20 or 30 years. So if we move the market or transition the market prematurely from HFC and don't have that supply available, it's going to mean you need to leave that technology, earlier than otherwise would be the case. So what we're really doing is supporting the market's transition and working alongside the phase downs that are occurring on HFCs to ensure at the same time we have that bridging of the gap that Reclaim HFC then creates for the market, offering therefore the breathing space while technicians get trained and upskilled and while that technology changeover therefore occurs. So look, I know we're out of time, but Elvira and I will be around after the session. Very happy to talk to anybody who would like any more information. Thank you.
Thank you, Lois and Elvira. It's just to confirm also that all these information presentations will be in our acknowledgement platform that called Spark Blue. We were going to share with you so you can have full access to the presentation and contacts. But in the meanwhile, just to see if you have any follow-up questions to, yes, I see a hand there in the back and 3 questions. Yeah.
Thank you. Considering the end-of-life management of equipment, in your opinion, how can the Protocol of Montreal address this situation and to promote maybe goals of refrigerant recovery? And also, in what cases the recovery of refrigerant is not financially sustainable? It's not possible.
I'll maybe answer the last part first, and then I'm going to turn to Elvira. Where it's not possible, I mean, there are some circumstances, obviously, where it's just not eligible. So, for example, CFCs. So where we're seeing, CFC as the focus, and we're recovering CFCs from the market globally, it would then be the case that we would take that product back and destroy that product using our TEEP-approved technology. There are also circumstances where refrigerant that's returned is so mixed that we'd need to destroy. With our technology, up to 5 mixed components can still be separated and brought back to virgin specification. But beyond that, there's circumstances it's just not economically viable to separate out the product. In terms of your first point about what can really be done then in terms of helping or supporting this, one thing we didn't get to mention, maybe you want to mention, is just on the difficulties to move product around.
That's right. So what we find is that when we do identify product in a country and that country doesn't have a local means to deal with it and it needs to be exported to a facility that we run, unfortunately, the Basel Convention gets in the way. And so that the movement of that material in order to access those LRM technologies gets very inhibitive. So it would be great for those obstacles to be somehow removed. And what we find is that different countries classify refrigerant or recovered refrigerant in different ways. Some countries classify it as a hazardous waste, others don't. Some are parties or signatories to the Basel Conventions, others aren't. So in order to get that movement to access these technologies, we need to find a smarter and a more seamless way of doing it, because the worst thing that can happen are perverse outcomes where people will not do the right thing and the material gets vented.
There was a second question. Yeah.
Hi, Elvira and Louise. Thanks for the presentation. I know that we're planning to team up on Thursday at this time to talk about voluntary carbon markets and their role in financing reclamation and destruction. But I was wondering if you could briefly touch on that for the audience and explain what the role of the voluntary carbon markets has been in supporting your business and also building scale for reclamation and destruction across the world. Thanks.
Hi. Look, absolutely, as I briefly touched on, being able to create carbon offsets from some of the activity that we undertake has certainly been a key enabler. So in the US, the material that we reclaim and then sell back into the market, which has been reclaimed within the US, is eligible for the creation of carbon offsets. Then in terms of that growth of the global business, we're recovering CFCs for destruction. From that activity, we're able to create carbon offsets. And what we're finding, as much as we all probably are aware, carbon offsets do have some bad press. For this type of activity, they are high integrity offsets because it's very permanent, it's very measurable. You can see the technology that it takes to create that offset. So fortunately for us, we're finding, as in fact there's some difficulties with carbon offsets from that naturals field, we're actually seeing an uptake in the types of offsets that we can create in the industrial sector, which are seen to have that high integrity. So that combination of methodologies which enable that offset creation, and then finding those commercial entities who are willing to pay the necessary price, certainly has been advantageous to increasing the amount of this activity that we're doing.
Methodology for that carbon market from the servicing. So if you are interested, we can share that methodology with you, and countries can use that methodology to put the real data, like the real cost, local cost to that, and that will be the result to show you whether it's feasible or not. So that was developed by our consultant.
Well,
for this purpose.
I'm not sure if that methodology you're talking about is the
through the Coupa.
Okay.
One last question. Yeah. The mic is reaching.
Hi, good day. Thank you, presenters, UNDP, and everyone who presented. For CO2 systems, and in particular, the transcritical and the cascading system, what was the average payback period for these type of systems? That's one question. And to AGAS, are there any, do you guys offer any technical assistance to some countries in the development of reclamation centers or destruction technology? Those are the two questions I have proposed. Thank you.
If we answer the second part first, and then I'll pass over on the CO2 question because I don't know the answer. On that side, yes, absolutely. Like we do work, and partner up with countries. We can, and at have times deployed our own technicians to travel into different countries to support on the recovery side. And then, yes, certainly, the long-term goal is to ensure that sort of ecosystem of recovery, reclamation, and destruction is developed in every country so that there isn't that need to be, transferring product around the world to access that technology. So certainly in terms of partnering up and undertaking that activity, very, very interested to talk to anyone that would like to. The CO2 part, someone else will have to answer.
Yes, with regard to the CO2 part, it of course depends on the project type, but a rule of thumb, retail industry and logistic industry, if you put together CapEx and OpEx, and if you're in a, let's say, more or less mature part of the introduction of the technology, you should have a recovery from 2.5 to 4 years. Considering that the lifespan of this equipment is well above 12 to 15 years. So it's considered a short recovery.
Yeah, thank you very much. I think we are running out of time, but I wanted to reinforce that all these presentations will be in our platform, and that's why we also asked you to fill the presence list so we can share you the links and the information. And also to bring to your attention that we are also, as we are running out of time, we are also going to post this presentation that is the results of the projects that UNDP helped countries to implement under the initial obligations of the KIPs, meaning the HFCs standalone projects. As you know, UNDP has been very active supporting countries with the HFCs phase down. And we have some of the early projects that were approved and fully implemented that are already showing results. So, for example, we have the project in Hisense Kelon, Hisense Kelon in China that works on the PU form side, because the refrigeration side of the domestic refrigeration is already highly efficient with variable speed compressors. So the solution to achieve even more stringent energy efficiency standards on Hisense Kelon was to improve the PU form mix that is based on 2,4,5 with hydrocarbons. Next one. In which we had a project approved for $1.2 million with a co-finance from $1.9 million in Hisense Kelon, which looked into the PU form part and did all the conversions and testing needed. And in the end, next one, please. And in the end, the company was able to achieve 1 to 2% on energy efficiency. That you may say, oh, it looks very small for the level of investment, but you need to bear in mind that the domestic refrigeration are already between the most efficient appliances in the market. And with standards, they still require much more efficient. But when you consider a company like Hisense, which places millions of equipment in the market that will run for maybe 10 or 15 years, it translates in more than 6 million kilowatts hour of energy that will be saved by these new models, and 5,000 metric tons of CO2 emissions that can be reduced by these products in the market. Another good example is Bangladesh, also in domestic refrigeration. This not focusing on part, but in the refrigeration side, meaning the compressor and the refrigeration sector, in which Walton is a leading market in Bangladesh that consumes almost 200 metric tons of 1,324A, translating in 282,000 tons of CO2 equivalent. And this is to respond to the national need, because Bangladesh today has a very low penetration of domestic refrigerators that is expected to boost in the next years, reaching 34 million units that the market will demand. So if you put this in terms of the future needs of country, if they continue to use 134A, but also the pressure on the energy grid that they will have, this can become a very serious project for Bangladesh. So at the same time that they are looking to achieve the goals of the Montreal Protocol, they have to handle this social and energy problem that was being created. So we have this project, was the very first approved in the HFC's window and the very first to be completed in 2019. Which counted with an investment of 3.1 million from the MLF, but in the end cost $7 million to be implemented. That included a full conversion of the plant, not only the refrigeration manufacturing, but also the compressor manufacturing. And because we are talking about hydrocarbon, also including the testing facilities, because this needs to be explosion proof. And in the end, we were able to squeeze between 10 to 30% of energy efficiency on the base model using induction compressor only by the new design and the improvement of some electrical components of the refrigerator. But if you include the new design of a compressor going to variable speed, we can achieve 26 to 41% of energy efficiency, which is a huge gain for the market. Next one. The third one is now in the commercial refrigeration manufacturing and the Farco industries in the Dominican Republic. Dominican Republic is a small country, so it has also, the industry is equivalent to the size of the demand of the country. But still, the country has to comply with the Montreal Protocol, so it's a source of 134A to be eliminated. There was also an investment from the Montreal Protocol of $180,000, but in the end, the real cost of the project was almost $700,000. Also involving the redesign of facility and equipment. In the end, the company was able to eliminate the use of 134A and 404 also, that is a very high GWP. Resulting in great saving, resulting in energy improvement of 30 to 60% based on in comparison to HFC and HC's model. Also, the design, modifications, the design improvement that is baseline, and also with improvement of electrical components such as lights and fans. And the last one, and the last one would be MABI. This is the older presentation, but there is also the MABI project. That is, MABI is one of the biggest Latin American manufacturers of domestic refrigerators, with more than 70 plants present in several countries that also converted the plant and the compressor design, and they were also able to achieve between 10 to 26% of energy efficiency in their products. So that's it. Thank you very much. We are available if you have any follow-up questions. In the communications we are going to send you, there will also be our email and contacts, and we remain available if you have any follow-up question once you digest a little bit more the information you're going to receive. Thank you, and have a good meeting and a good week.
Sure.